Okay, welcome back, everyone. We're here for part 2 of our smart contract security workshop with Lawrence from Extropy. Lawrence, welcome back.
Thank you.
Okay, I hope you had a time to get a drink, maybe walk outside, get some fresh air. I don't know.
I had a cup of tea.
I had a cup of tea. Wonderful. Okay, cool. So I don't want to delay from the content here or take away from it. So I'm going to turn it over to you. And then when you're ready to wrap up, just give me the signal and we'll come back and chat for a minute. Okay.
Great. Thanks, Craig.
Thanks so much, Lawrence.
Thank you. Hey, everyone. Welcome back. Yeah, I hope you're all refreshed and ready to dig into a little bit more about security. So I'm going to look now at some of the tokens we have, some of the token standards that we have and the security features around those. I realized during the break that the notes weren't quite updated. So I've updated them now. So hopefully if you just refresh your page, you should get the updated version. All right, so we'll start off with the fungible token. So we're looking at LSP7. So this is the follow-on from the ERC20 standard, and but it does have some as well. So it has more functionality, more flexibility, and then there are some security aspects to that as well. So we'll talk about those and talk about how this can be used. So one of the first points is this idea of the force parameter for secure transfer. So a flag building parameter added to the transfer function, and the idea behind this comes from the way the ERC20 started to be used, and some people started to do things like safe transfer on Ethereum because they realized that when we're doing a transfer of an asset, we want a little bit more control over that. The very vanilla, the very basic way that is done in an ERC20 is that the transfer happens. We change a mapping or something in or value in a mapping so that a new address has some tokens. But that's really all there is to it, and the person involved, the receiver of those tokens, doesn't get a say in this process. And excuse me, this can be problematic from a number of ways. So it could be that you would accidentally transfer tokens to a contract that isn't really capable of doing anything with those tokens, and then those tokens are effectively lost. So we would like to be able to transfer tokens only to something that will be able to handle the tokens. And then also there are some attacks that happens. You may well have had these, they're called dusting attacks, I think, where you will get dropped some tokens, or there'll be some sort of malicious airdrop that happens, and you will just suddenly receive tokens in your wallet that you didn't want, and it's to try to so sort of the beginning of a phishing attack, that kind of thing. So to try to prevent all of that, we have some extra features in LSP7 that are there to give us more control. So both from the sender point of view and from the receiver point of view. So the first one, the force parameter here, what this gives us is that it requires the recipient to implement the universal receiver, the LSP1. And this is to try to prevent accidental transfers to incompatible contracts. So I got some example code of how you may want to implement this. There we go. To implement this functionality, so you can have a look through this. But the point we have here, we've got really a couple of pieces to this. So first of all, we do allow recipients to opt out of this, and there's a way that they can do that, in which case this will then revert. So the transfer would revert if the recipient has opted out of a forced transfer. And if then it's not forced, then we can also reject as well. We can also revert if it's not accepted. Okay, and then we have a way to check the acceptance for the recipient, to check that it is capable of receiving the token. So there's quite a lot of choices there, quite a lot of functionality that you can put into your transfer and well into your token generally by doing that. Other points as well, other things we get with LSP7 is around the authorization. So the equivalence of the approval, the allowance sort of mechanism that we had with ERC20, but taking that further, so giving us more granularity with that. So I'll talk a little bit about that more in a second. And certainly this removes one of the, or reduces one of the problems that you do see still with some people when they're using ERC20, where they give unlimited approvals. And they do this for convenience because they don't want to have to keep changing the approvals or adding to an approval. But it is potentially a very risky thing to do, because if you're approving to an address and that address is compromised, then you could effectively lose all your tokens. So what does this mean in terms of best practices overall? Well, in client applications, we can default to false for the force. We can put an expiry on for the authorization. So this is an extra flexibility around the authorization, and allows us to expire that after a certain time. We've got the idea of a hook implementation, which I'm going to talk much more about a little bit later. But this, we can use these, but they do also open up a possible problem. So you have to make sure that you validate the way that these work. And if you're using the universal receiver, then you need to make sure that you've got all of the correct checks in there according to the functionality that you want. So what I've got here is just a simple table to sum up some of the differences and between the RC20 and the LSP7 transfer, just to give you an overview of that. So you can see, I think I've talked about most of those, and you can see there's extra pieces that we have in the LSP7. So to give you some further examples of that, for example, we can add specific business purpose when we have an authorization. So you can see here, you can specify what that might be there. So you're giving more details about the authorization that you're setting up. We're giving some context for that. This idea here, the idea of the rejection, is what I was saying, where you don't want to receive some token. So you can check with the universal receiver, then you can check whether you want to be receiving these tokens and then act accordingly. So you've got the example here of rejecting a transfer, and you could set up a list based on address of the sender to say which addresses you are going to accept tokens from. So that means you can reject those, and then you're not going to get the malicious airdrops. Maybe you want to reject large transfers, so you can do that. It gives you a lot of flexibility around that. And then you can take this further as well. With we're back here looking at how the transfer would be implemented, and other things that you could put into that will be to do tiers of authorization. So you can see here we've set up some different tiers and some caps around the amount that can be authorized. So we've set up well, just 3 here for various different amounts, and then you've got an admin tier that doesn't have any restrictions. So yeah, and then you can specify those in a mapping, as you can see there. And so that gives you more flexibility again of how you're going to do authorization, much more granularity. And just to sort of show you some of how this could then benefit you and sort of be applied, I've just given you some examples here of how you could use this extra functionality. So with the idea that you've got an expiry on the authorization, then you could have some recurring payments, but that authorization for that recurring payment will expire after a certain while to stop that being abused. You could have this being used for compliance as well. If you have some sort of compliance checks when you're looking at the recipient, then those could be introduced to check there. This point here is the point about having metadata available, so that when transfers happen, you can see the context that was done. The anti-scam, the point here is that you're not getting these malicious airdrops, and the multi-party transactions are useful if you want something quite complex. You want an escrow or maybe a conditional transfer. You want to be able to transfer tokens conditional on a something else happening. So you can set all of that logic up much more easily with the LSP7 standard. Okay, and that brings me on to the LSP8. So this is where we are. We have an identifiable asset, so it's not a fungible asset. So this is really the base of the NFT standard. And again, we've got more granularity, more flexibility in what we're able to do. For example, the way that we identify the assets, we have multiple formats for that. But then that must be validated. You should be validating that format in your implementation. Otherwise, you could get the problem that you have some ID that just doesn't make sense. So you should always be validating. Well, you should always validate all inputs to all of your functions, but certainly something like an idea is going to be particularly important. This point here, back again with the idea of authorization. So this is fundamentally a little different for the non-fungible tokens compared to the fungible tokens, because with fungible tokens, we can't really specify that we're going to authorize a particular token, because that's really the meaning of fungibility, that they're all the same. But because these are identifiable, this means that we can do an authorization on a per token basis, which could be very useful. It could mean that you would allow, say, someone to spend or to transfer some low value NFTs on your behalf, but not a high value example of that NFT. So yeah, there's extra functionality there. But in terms of security, the best practices, well, we need to be checking that the token IDs are correct. We have the right format, and that these are consistent. The security should be as comprehensive as possible. So try to make it as general as possible when you're putting in the logic around the security. And then we have supplied for us the idea of the universal receiver, again, that allows us to check when we're receiving tokens whether we want to do that. And on the NFT side, I mean, this could be you're checking against the the sender, or you could do something more complex. You could be checking that this particular NFT is from a certain collection, because you've got much more data available to you. You've got a lot of metadata available to you as well, and you can accept or reject based on that. So yeah, a lot more. And really, again, it comes down from a security point of view. The best thing is the idea of the least privilege. So lock down things as much as you can, and then just open them up as needed, because we have the flexibility to adjust this. So you can adjust, for example, where you would be receiving tokens from. So if you just adjust that as necessary, and don't accept tokens from anywhere, then that will stop you getting tokens from a malicious airdrop, for example. Okay, let me move on. So, oh yeah, I think I've sort of said some of this already. So this is looking at it more now from the operator point of view, and looking particularly at the authorization of that. So some of the key points here is that we can be much more specific. So we can do this based on a token level rather than the account level, as you can see here. So really, this is what I was just saying actually before. So this gives us more granularity than the standard ERC 721. So we can authorize for specific tokens. These are the methods that we have to do that. So we can authorize and we can revoke as well. And we can have multiple operators being authorized as well, which again gives us much more flexibility. But from a security point of view, again, we've got the force parameter, so we need to think about that. And if it's not true, if you're set to false, then you should validate that the recipient is implementing the receiver, the LSP1 standard, and this helps prevent accidental loss. This is, I think, is an interesting point. It may seem trivial, but having audited contracts, this has come up numerous times where and I'm thinking here now of on the traditional EVM contracts, where we have advised people that they may want to add a method into a contract in case they receive tokens, so that they can accidentally, so that they can transfer them back. The downside of doing something like that then is that introduces a centralization risk. If you have a method within your sort of function within your contract that allows an administrator to remove tokens or to send tokens that have been sent there, then that could potentially open up a security risk as well. And that kind of choice that we get into a situation where, on one side we've got a security risk, on the other side we've got potential that people could lose tokens by accidentally sending them to the contract. And, it's not really a satisfactory situation to be in. We would like to avoid having to make this choice. And I know, sometimes when we've audited and suggested this to clients, they've come back to say, well, actually, if people send tokens to us, well, that's their problem. They lose them and we're not responsible for that. But it would be nicer to have a choice and a better way of dealing with that. And that's what all of this extra functionality around tokens, that's what that helps to give us. But make sure when you're doing this that you're doing this correctly. So make sure you implement these checks correctly. Make sure that if you do have an invalid recipient, that you are going to revert. You're going to prevent the transfer. And if you're going to try to force this, then there should be proper authorization around that. And yeah, this point about the LSP 8 versus 7 is really just the difference in the way that we use these different types of tokens. Okay. Right. So I said we had this idea of the universal receiver, and this can help us when we are sending tokens. So we get this idea of having hooks available. So this is quite a powerful feature, and again, something that you do see this elsewhere. People have tried to implement this as well. So this can be a valuable thing to be able to do, but there are some potential vulnerabilities associated with it. So certainly use it, but because it gives you flexibility and extra functionality, but be careful when you're using it that you're not introducing any security problems. So the idea is that the receiving contract can be notified about incoming tokens. So this is the notification hook. The way that we handle this is that we have constants, these type IDs that are identifying the types of transactions. So those are involved in the universal receiver. And what this gives us then is allows us to add logic in to what happens if we are receiving tokens, if our contract is going to receive tokens, including rejection. So we may want to reject receiving tokens, or we may want to do something else. The idea of the hook is that we have this space then to put in some logic about that. So that's all good. We want to be able to have that flexibility and that functionality, but it can lead to some vulnerabilities. And one of the most obvious, I suppose, is the idea of reentrancy. So the original reentrancy, the most famous reentrancy attack, happened because we effectively had this kind of hook in the fallback function in a contract. So there was a transfer happening, which was picked up, or I suppose it's received now, but that was picked up at the time, and then there was a reentrancy because the receiving contract then called back to the sending contract and called the function again. So with a hook, we could potentially do the same type of reentrancy attack. So you do need to be aware of people doing that. And there are permissions that you can set around that. So that can be a way to mitigate against that. We have guards as well that we can use against reentrancy. Another point to be careful about is that the operations that could happen in the hook could introduce a denial of service. You could do something that is going to revert because it's out of gas, for example, something that could be very expensive. So that could be a way that a malicious hook could block a transfer. Or that could just be some malicious logic happening within the hook implementation. Okay, so do be aware of that when you're using hooks. Okay, so I think this is just going in more detail, but yeah, it's going through the advantages. Yeah, I think this is really just a summary here. So if you want to prevent the reentrancy, then you need to be thinking about the reentrancy permission. If that makes sense for your contract to allow that. Again, think of it from the point of view of being as restrictive as possible. So only allow this if you really must have that permission. yeah, I've spoken about this idea here, the gas consumption and DOS. One useful thing about the way that the LSP1 has been implemented is that we've got a standard way of doing this now. So because this wasn't part of the original functionality of ERC20, and as token standards sort of developed on Ethereum, they all started to do their own thing. So we got quite a mix. But with LSP1, we've got this done in a standard way, and this helps with security. This means that we can check that we are doing things correctly and know that know what problems there are. If there was a problem in the way this was implemented in one contract, then you would know that that could be a problem for you. So having it as a standard is important, and but you need to make sure you understand the pattern and you do that correctly. As I said, permission management helped with reentrancy. We've got standardization. So the best practices in general around callback hooks. So use reentrancy guards, as needed. If you are doing a callback, keep the logic simple and gas efficient. Do proper validation and test extensively. I'll come on to this a little bit more later, actually. I'll talk a little bit more about testing. But be aware that, certainly when you're testing as well, that the ecosystems we have now on within blockchains, particularly within DeFi, there is this move or this motivation and desire to put a lot of put a lot of things together, and the ecosystems that are built up can become quite complex. So do be aware of the fact that your callbacks could be in quite a complex ecosystem, and so be aware of how that could be a security problem. Okay, so just in conclusion, the callback hooks are very useful, but you do need to be aware of potential problems with them, and particularly things like reentrancy and how you can mitigate against those. Okay. So I wanted to do some sort of hands-on examples, but it's what I thought I would do then is show you a couple of examples, and then give some for you to do in your own time. And what I will do is I will then provide some answers for those. I'll put them on the same site, and then you can check those. So this is some ideas about security, so just in general now. So this first one is around the key manager and permissions. So the question here is to implement the key manager, but in a particular scenario, so that we get a call permission, but we don't have allowed call restrictions. So this is too permissive. We want this to be more restricted. So that's the first example here. You've got so you've just got the permission there, but you haven't set up any other restrictions on what is allowed there. This next one is the idea of allowing a controller permissions to do call and set data in a way that could escalate privileges. So this is what I was saying earlier about if you are doing a combination of permissions, that you need to be careful. So here you got the point that this is allowing an attacker to escalate their own, to modify their own permissions, to increase their own permissions there. So have a work through that, have a look through that, make sure you understand that, and appreciate how careful you have to be when you are combining permissions. So that's a couple of examples. So I just leave the rest for you to do yourselves. You can try them out, and as I say, I'll provide examples of these as well. So I think I don't need to really explain much more about them. This is things we've been talking. I mean, we talked about this very much in the last session, and then in this current session, we've been talking about. In the last session we talked about ownership transfer, and yeah, the key permissions, and then we talked in this session about the receiving tokens and how that can be done securely, and then more here about token implementation. About token security here for fungible tokens, so the LSP 7. So to give an idea of how to do a forced transfer, implement that correctly, how to implement authorization correctly, an example of a safe hook, and how that can handle receiving tokens, and do some security around metadata as well, thinking about because we have metadata available in the LSP 7 as well, so you could use metadata as well and do security around that. Okay. All right. So I can talk then generally now. I think I'll just sort of talk generally about security best practices, and I'll come on to. I've talked more about specifics. So I want to talk more generally now about some of the recommendations and best practices as well. So first of all, the point about auditing, we can use tools. I'll talk about tools in a second as well. But my experience of using tools is that although they are useful, and they, there's, because they're mostly relatively performant, so there's no real drawback to using them. For static analysis tools can analyze your contracts fairly quickly, so it's worthwhile using them. One problem with them can be that you get a lot of false positives, so you could spend a lot of time working through those, but still it's worth having them and trying them out rather than not. But don't have too much reliance upon them, and particularly because if you take a static analysis tool like Slither, those tools have been written using patterns that are patterns of vulnerabilities that are known about on Ethereum. They're not going to have some of the specific vulnerabilities that we've been speaking about today. So don't be over reliant on them, and don't have too high expectations of what they are going to find. That's the reason that you should always get your code audited, whatever way you do that, whether that's through a formal audit or a security review, or getting some of your colleagues to look through your code and do an audit. I'll talk a little bit more about that in a second. Actually, I'll come back to some of the points about that. Testing, particularly around permissions, where we've just seen the point that when you start to combine permissions, you need to make sure that you're testing those combinations extensively, and looking for any possibility that there could be escalation of privilege because of the combination. Use factories for deployment so that you don't get a misconfiguration. Keep up with the updates. So that means being aware of the standards, being aware of the standards so that you know how to implement them correctly, implement them securely and efficiently. So make sure you have a good understanding of the standards. But then they may evolve over time, so make sure you keep up to date with those. And error handling. So this is an area that is often neglected. So make sure that is done correctly and according to the standards that you are using. If you're thinking as an attacker, what sort of things you might want to do. One of the first things you would probably try is to try to cause an error within a contract and then see what that could potentially lead to. If that error isn't handled correctly, could that lead to some misconfiguration in the contract that you could exploit, or lead to some escalation of privilege, something like that? So don't think that error handling is just nice to have. Make sure that is tested for security as well. I've got a very short, quick checklist here that you can have a look at, just to remind you. It's always worth having checklists because something might slip your memory. So it's always worth working through them. This first point, I've been saying the idea of the following the least privilege principle. So just lock everything down as much as possible, and then just open things up and give permissions only when needed. Second point, avoid delegate call. We've spoken about the permission data keys as well, and how you can structure those. Don't make them too permissive, with the use of wildcards, and make sure that they are being correctly checked. Force parameter, we've spoken about that. If you're using hooks, then look at the possibility of reentrancy. If you have extensions, then those need to be validated correctly. Ownership, we have this two-step pattern, the standard there for you to use, so follow that, and that avoids you transferring ownership to the wrong address. You do still need to manage nonces as well when you're creating transactions, so make sure that is done correctly, because for relayers, that needs to be done correctly, so that you don't get the possibility of transactions being replayed. And signature validation, obviously you need to follow the standards for that, and we have standards available for that also. Okay, so we recently did some security reviews of a couple of projects on LUKSO, and I just wanted to share some of the points from them. I don't want to show you the actual reviews themselves. I can make them available if the projects are happy with that, but I really wanted to talk about them more generally. And one point that came out of that, which is true generally, this didn't surprise me, was that a lot of the issues that we found were around application logic. That if you are doing an audit or doing a security review, that is probably going to be the case. You do get a lot of those types of errors, but that doesn't mean you shouldn't be looking for more specific problems as well. And we did find some that were more specific to the LUKSO standards, so, for example, using delegate call, there was also some issues around the way the ERC 725Y storage was being used as well. That came out of that. So, if you're doing a review, you will get vulnerabilities or issues just because of application logic. But there are, you still should be looking for things that are more LUKSO specific. Okay, so brings me on to the point about security in general. And the way I like to think about this is that when you're I suppose I'm thinking here, looking at this from maybe with an auditor's perspective, but it still applies to developers as well. But the way I like to think of it is that, we have increasing layers of security to think about. So, in the lowest layers, you've got things like sort of operational security and network security and those type of things. And then on top of that, we've got sort of Web 2 aspects maybe, or application logic things to think about. Then we've got Web 3 points to think about, and then on top of all of that, we've got things that are more specific to LUKSO. So you need to be aware of all of those things when you're developing, and or if you're auditing or reviewing security. You need to be aware that there could be problems at any of these layers. Now, some of them will be perhaps more important than others. Some of them you may know are less relevant because perhaps it's part of a protocol that has already been audited, so you can perhaps be more aware that is going to be safe. But still, you do need to be really thinking of it, quite holistically, I suppose, and thinking that there could be problems in many different areas that you need to be thinking about and aware of. Other things that for the developer, I suppose, to think about is that although we're working in Web3, this doesn't mean we should be forgetting the best practices that have been found and researched and developed over the years in software development and the general development life cycle. So please still use those best practices when you're developing your project. So that means things like testing. And one point that I think is still quite rare that I would like to talk about with regards to testing is that the way that people write tests, if we think, for example, about unit tests, what people will often do is they'll have some functionality that they want to implement, and then they will write some tests to show that piece of functionality now works to some extent. So they will be following the kind of the happy path, and then they'll have a test to show that gives back the desired result. But that's really only part of the picture, and that's really only part of what you should be testing. You should also be testing for unexpected things and niche conditions, and things like fuzz testing are very good approaches to use for that. But also, I think a good way to approach this is to try to break your code, and this is often quite difficult for people to do. They've spent time creating, designing and implementing this some code, and to then try to break it is quite a difficult thing to think about, quite a difficult shift in mindset. But it is really valuable, and it could be that you would get someone else to try to break it, but you really do need that type of mindset to go in and try to do your best to break the code, because that is what an attacker will be trying to do. So you want to be writing tests to show that these, the ways that you've got of breaking the code are not succeeding, and that you've got proof that code can't be broken in that particular way. Then hopefully you'll have lots of unit tests that will give good coverage of your code. Whether you want to follow some particular approaches such as test-driven development or business-driven development, or whatever you want to do, you still should end up with a good test suite, unit tests, integration tests, all of those things. And these are well-known things. But then when your code is finished, then it needs to be audited. As I said, whether that's a formal audit, whether it's asking your colleagues to go through the code and try to break it, whatever it is, whether it's a more informal security review, you do need other people's eyes on your code. And the reason is that one of the areas, the way that code becomes vulnerable, can often be that a developer has a mental model of how he thinks the code is going to work, but that is an incomplete model. He's forgotten something. He's got some kind of blind spot there, and he's developed the code with that, and when he's written the tests, that incomplete understanding still applies. So his tests will also be missing this problem. So that's why it's really useful to get someone else's view of your code and get someone who has a fresh pair of eyes, is looking at the code fresh, and hopefully won't have the same blind spot, and maybe will be able to find that. So yeah, that's why auditing, whatever form that takes, is really essential. And then that's not the end of the process. Once you've done that, you've got your code deployed, then you should be monitoring. There are tools out there to help you with monitoring, but you should be monitoring what is happening and looking for strange behavior. We are quite fortunate that there are white hat hacking teams out there that will also be doing this. So sometimes you find them, that they will spot vulnerabilities, or they will see a problem developing. There are also things like the Forta network on Ethereum that do a similar thing, that look for vulnerabilities being exploited and those things developing. But you can't rely on those. So you should be doing your own monitoring. Look for unusual behavior. Look for things that you don't want to happen, you're not expecting. For example, if you have a contract that has a certain balance, which is you expect it to be, always increasing. If that starts to drop, then maybe your contract's being attacked and people are stealing funds. So have some monitoring in place to look for that. And there are tools that allow you to automate this and to send you alerts dependent on certain conditions. So make the most of those. Other things to do as well, stay up to date with recent exploits. If you haven't been reading Rect News, you've been missing out. It's a great resource. It has a very good understanding of the blockchains generally, particularly DeFi, and has really good write-ups of exploits. And you do get copycat exploits. So if there is a particular pattern in a contract that is vulnerable and is exploited, then you can be sure that then malicious people will be looking for that same pattern in other contracts. So if your contract is also vulnerable, then it's time to take some action to upgrade it or whatever. So staying up to date will certainly help you with that. Yeah. Okay, just a quick little bit before we end about Extropy, because I didn't really introduce us. So we're a Web3 consultancy. We specialize in security and education. We also do development, but we do more security and education now. We've been running workshops for a long time. These are some photos. The first one on the top left there was I think in 2017, early on. But yeah, we've done lots of workshops. These were all done. These were all in London when we were able to do them in person. We had to move online because of COVID. We're hoping to start to do some more in person again. So yeah, fingers crossed we may see some people as well. We have further resources for you. So we've got our security website that has general resources, but also we have audit reports there. So for some of the audits we've done, we've got the reports there. They're worth having a look at, reading through those. It does help build up your security expertise by reading through reports. If you want to get in touch with us, please do. You can join our Discord server. You can follow us on LinkedIn. We are going to do some more courses. So we already do courses through Encode. We do boot camps with them, but we're also going to be running our own courses as well. We're going to be doing some more advanced courses around Solidity. So if you follow us, you'll see the announcements about that. And we'll also be doing courses around security and auditing as well. If you would like to talk to us about your project, if you would like either a security review or a full audit, then there's our email address there. You can contact us. We're happy to have a chat with you about that. Okay, well, that's everything. I'll finish there. Yeah, these notes are available at luxo.bootcampnotes.xyz. That site's going to stay there. I'll update the notes with some of the examples from the hands-on lab. So I'll give you some more examples there if you want to try things out. Also, if you have any comments, please let me know. If there's any typos in the notes, I'll update those as well. But yeah, that's everything from me. Thank you for your attendance today. I hope you've enjoyed that and found that useful. And please, yeah, be secure, write secure code. I hate to see projects getting exploited. So yeah, thank you, everyone. That's everything from me. Over to you, Craig.
Lawrence, thank you so much again for a really comprehensive set of workshops this morning. I know you couldn't possibly get as deep as you need to get on a lot of these topics, but it certainly exposed our viewing audience to a lot of the most important topics out there. And I feel like now they have a foothold in areas where they can dig deeper. And thank you for providing the socials at the end so they can get in touch with Extropy and continue their education, because upskilling is obviously something we all need to do in this field. Yeah, awesome. So Lawrence, thank you.
Thank you.
Community, you know how to get in touch, and that it will be the end of these workshops from Extropy. So Lawrence, have a great evening in London, and we'll talk soon.
Great. Thanks, Craig. Thanks, everyone. Bye-bye.
Thanks so much.